Hi, I'm Fred Gould in the Entomology and Genetics Department. I'm going to tell you just a little bit about transgenic plants and transgenic pests. So this is a nice mouth-watering view of sweet corn in the summer. I'm sure many of you have imbibed. And some of you who do your own shucking of corn have seen this, right? Yeah. And that's the corn earworm. And typically, corn in North Carolina and other places can have up to 11 sprays of insecticide to protect you from seeing this. But organic farmers have long used a formulation of a bacteria, Bacillus thuringiensis, that also kills this insect. Over the last 15 years, molecular geneticists have taken a gene from that bacteria that produces a toxic protein and moved that into the genomes of corn plants and yielded protection. And this is a protection actually of corn that is conventional corn in the same field as here the transgenic corn with the Bt toxin in it. So decreasing the impacts of those pests. But not everybody is very happy with that. And right now, there is actually a controversy going over with the possibility this summer of Walmart actually marketing sweet corn that has the Bt toxin in it. So far, most of the Bt corn is field corn. So it's clear that the public isn't all on board about this in the United States and even more so in Europe. So we have worked on these issues for quite a while. Most of our contribution has been in trying to figure out how to make this more sustainable so that the insects won't adapt to the Bt toxins by having some, this is a picture for cotton, similar kind of thing with the Bt in the cotton, to have some of the cotton grown without the Bt in it and other parts of the cotton areas with the Bt so that the insects that are susceptible will dilute the resistance. But we've moved on from that with assistance from lots of grower groups and industry and the government to actually making this sort of a national policy of having these refuges so that insects will not adapt. And it's been working fairly well when the regulations are adhered to. But the moving on really is moving on from having transgenic plants to protect against pests to having transgenic pests to protect against themselves, okay? And let me explain that. So here's just an example of a mosquito, Aedes aegypti. This is a normal one, and this is one that's been genetically engineered, and the fluorescent green is just a marker. The important part about it is that genes are expressed in the midgut of the female after she takes a blood meal. And the genes that are expressed will make it so that the dengue virus cannot replicate in the midgut and be transmitted to other people. So the idea behind this is to develop transgenic mosquitoes that can't transmit dengue. In the same way, transgenic mosquitoes are being developed that can't transmit malaria. And there's actually a booth next door that Marseille Lorenzen and Max Scott have put out that will give you more information about the details. But the important thing here is that just developing an insect that doesn't transmit malaria or dengue and putting it out in the field is not too important. If this is the little critter that doesn't transmit dengue, but you have plenty of other ones that do transmit, it's not going to help too much. So the little trick is to connect those genes to selfish genes that will spread the genes through the population so that you put out a few and in the end they take over. You can imagine that this is not always that acceptable to the public to think about transgenes moving. So we tried to develop a group at NC State originally by pulling together ecologists, molecular biologists, and population geneticists to address this question, but we quickly realized that we needed to go more diverse. And so we included people on our NC State campus in policy, social sciences, and ethics, and brought together a group to write a grant proposal to the National Science Foundation to evaluate these transgenic pests. It's a very broad group of co-PIs, and we got a National Science Foundation grant, which we've just started out. And this just gives you a picture of the people all over campus who have been involved, all the faculty. The idea was to recruit graduate students from these different areas as undergraduates and have them sort of learn each other's pieces so they become partial experts in all of those fields. And now we have our first 6 students who are starting in July, and we're going to be taking them for their first course to Iquitos, Peru, where they're going to be investigating dengue and approaches from the social sciences and the biological sciences to look at holistic approaches. Thank you.